I'm going to hand the microphone over to my colleague here who's going to take us through the field control system software and using the Samantha module.
Okay, so the first thing we'll talk about is our FCS, or Field Control System software. This software is what you run on your PC to connect to your Samantha module. And the Samantha module, in turn, connects with your NXT brick. And it does this over the Wi-Fi network, so you're no longer limited to the range of a USB cable or the 30 feet that a Bluetooth connection will give you. Now we'll talk about connecting to the Samantha module. As I said, the Samantha module allows you to communicate with your robot over a Wi-Fi network. You can either use an ad hoc or an infrastructure network. An ad hoc network is one that just has a few devices communicating directly to each other, whereas an infrastructure will have a router connected to a gateway, and then several devices would connect to your router. And when you connect to your Samantha module over Wi-Fi, it's going to be communicating with your NXT brick by a USB cable that's all mounted on your robot. So now let's go ahead and take a look at what the FCS software looks like. This is the FCS software. The first thing that's actually going to pop up when you open it is your setup joystick. So you have your joystick set up, and as you can see here, we have a question mark flashing. It wants us to define what controller is going to be used here. So I'll go ahead and I'll click that, and I'll just press a button on my controller. And as we can see, there are 4 teams. We can have up to 4 teams in one match. And for each of those 4 teams, we can also have 2 drivers. So you can define several controllers and what controller is going to correspond to what driver for which team. So we'll go ahead and click OK. Also, we can open up our configuration here, and there's a number of options that we can look at here. During our match, there's an autonomous time period, there's a teleop time period, and we can also define whether or not we want a pause between them. If we have this checked, then we're going to have to click continue before our teleop executes. And again, we can choose exactly how we want our match to consist of, and also when our end of match warning occurs. Also down here we can play with the different colors that happen depending on different warnings, and we can also set everything back to default if we want. Also, during the match running, we can open up a timer display here that just shows a graphical view of all our batteries, our connection settings, and also the timer countdown for the current state of the match. As we can see, our current mode is idle. Let's go ahead and connect to our FCS module. To do that, we'll simply go choose, and if it doesn't show up, just hit rescan, and we can see our FCS module here. FTC is the name of our NXT brick. We'll go ahead and click OK. Now, if you're having trouble connecting, it's best to just power down your Samantha module, power it back on, same with your NXT brick, and sometimes that'll solve the problem. But before you can even get to this point, you're going to have to download this software, and I'll show you where you can get that from. We'll open up our internet browser here, and we'll take you to usfirst.org. To get to our FCS software, go Robotic Programs, go to the First Tech Challenge, and on the left here, click Samantha Resources. This page has a wealth of resources for you. First of all, this link here is where you're going to actually download the FCS software. When you download it, you're going to end up with an exe executable file. This is actually just an installer. After you install your software, you're going to end up in your program files with some configuration files as well as some diagnostic programs that you can run. But the most important thing is a configuration file called samantha.hex. This is your firmware file. You're going to have to toss this onto a USB memory stick that is less than 2 gigabytes, and then you're going to have to plug it into your Samantha module and then power it on, and that will update your firmware. The next thing you're going to have to do is configure your network settings. In order to do that, it also installs a network configuration program. You just open it up and you type in your network settings, including the SSID broadcast name as well as your encryption settings, and it'll go ahead and toss that onto a USB stick as well. Use the same process to upload your network settings as you did for your firmware configuration settings. And assuming you did all that correctly and it works, you'll be able to connect like I have right there. Also worth pointing out is there's a lot of resources on this page as well. There's a router configuration guide, and there's also some best practices for mounting your Samantha module onto your robot. And possibly one of the most accessible ways to get help is the forum. You can log on and ask questions, and there will be people there that'll help you out. So we'll go back to our software, and we'll notice that it says no program running. There's also a few things here about our voltage for our NXT as well as our Tetrix battery. If we want more details about our robot, we can click Details. We can see we have our name, our IP address, voltages, what teleop program it's going to run, as well as the current program running. And we'll notice again that it's blank because we don't have one running. We can also click the IP address here, and it'll open up a page here that has lots of info about our robot, including wireless settings and voltages and data that's being sent between our computer and our Samantha module. So the question is, what do you do now? Well, now you're going to have to upload a program to run. So now I'm going to go back to Ben, and he is going to talk about code templates.
Thanks, Greg. So we've talked before, and we all know how the basic functionality of FTC competitions are, is that there's an autonomous mode, then followed by a teleop mode. And in the autonomous mode, you're programming your robot to perform actions based on either pre-programmed choices or input from its various sensors. And in the teleop mode, of course, you're driving it with a joystick controller. There are certain templates that need to be followed to make sure that your code runs properly and legally in the competition. And within the LabVIEW context, we're going to take just a very quick look at one of the examples of an autonomous template and one of the examples of a teleop template. And again, I'll reiterate that the creation of these templates is going to be covered in a lot more detail in the next webinar. One of the most important features that the templates have to perform is to actually wait for the FCS. Our robot cannot start moving until it's time in the competition for all the robots to move. That is the whole purpose of the field control system. So that's why we must follow our template. I'm going to return into LabVIEW. Right here we're looking at a robot project which contains already a teleop mode, an autonomous mode, and an autonomous example. And we're going to start off looking at an empty autonomous example. So when you create a new robot project, this will automatically be sitting there in your Robot Project Center screen. What you see here is a really clear indication that your autonomous code goes here. And what we could do is we could take the same code that we created in the last webinar to perform those various actions and make those various decisions based on the line following sensors as well as the touch sensor and based on the proximity to an object. We could take that code and have created it from scratch inside this sequence structure. And that's exactly how you'll proceed when you go ahead to create the code for your robot for this competition season. I do want to take just a moment though and explain what you see here, because quite often curious students and mentors ask. So there's a clearly labeled communications loop. And I'll bring up my convenient context help by clicking on the question mark. Hover over each of these, we see that there's three functions here. One which reads a packet, one which gets a connection status, and one which disables the robot. Those three functions run in order, and the end result is a robot that's in the correct state and a result as to which state that is. And there's a comparison function that's saying, is that state enabled? And if the answer is true, it's being written to a front panel indicator. And if you'll remember and think carefully of the way we discussed how LabVIEW code works, when there's no wires between structures or functions, they run in parallel. So in reality, this communications loop is always running. This bottom section of code is running also in parallel with the communications loop. So there has to be a way that these two loops can talk to each other. And there's a structure here called a local variable, which is reading the value of that enabled. So really what's happening is our code is sitting here in this loop with a 20 millisecond delay running over and over and over again until enabled is true. And then, because there's a wire connecting these structures together, the code inside the sequence structure can run. That's the mechanism that is used in the autonomous mode to make sure that we're waiting for the FCS signal to make everything legal to go.
Okay, so now I'm going to talk about actually running our code within our FCS software. So we'll close these out and we'll open up an example that we already have built here. And we're going to talk about this code in much more detail in the next webinar. But as we can see, we have an example autonomous program set. It lies within the sequence structure here where it's meant to be placed. We still have our communications loop, and that's key for when we run in our FCS, because what that's going to do is it's going to make this program wait. So I'll go ahead and I will deploy that onto our NXT brick.
We'll wait a moment for Murphy from Murphy's Law to have his time. There we go.
Oh.
It's deploying.
So once this program actually starts to run and downloads to our brick, if you look at your NXT screen, all it's going to say is offline in capital letters. That's because it is currently waiting for the FCS to tell it to actually run this code. Despite the fact that it is technically running, it's waiting for the FCS to tell it to run what's in our sequence structure here. So we'll go ahead to our FCS software. And before, you would have noticed that it said no program running in this little status box here, whereas it no longer does. It now recognizes that there is a program running. And we see our current mode is idle. So what we can do is we can go ahead and go start match. You can see our mode goes to autonomous. You can probably hear our motors running in the background here. You can also see that our timers counting down are autonomous. It also tells us a little bit about the match, how much time is in each one. We can also see over here that we can stop at any time by pressing this button here. We also get readouts here about our voltages in real time. We'll just go ahead and wait for autonomous mode to be over. Now we can see it's entered our waiting period. And if we go ahead and hit continue here, it's now going to enter our teleop mode. And if you look at this green button here, as I press buttons on the controller, you can see that it's picking those up. And depending on how you've programmed your teleop code, again, we'll go over the teleop code a lot more in our next webinar, but this is the time in which the teleop code will run, and you can actually control it with your remote controller. So we'll go ahead and stop the match. And that's really all there is to using the FCS software for running programs. And again, really the whole reason for this is so that you can coordinate all your teams. If you're gonna have 4 teams going, if you were to all just click run on a brick and have it run, this allows you to all actually start the match and run under the same timelines at the same time, and this just automates it and takes care of it for you. Okay. And again, we talked about running code with the FCS. When running code from our templates, the code will wait for our signal, and it allows you to coordinate an entire FCS match.
Great. Well, as mentioned, we're going to go into a lot more detail in the next webinar about how to actually make the changes that you need to the teleop and the autonomous code to get down the path of making your robot do exactly what you need it to for this year's competition. Well, thank you very much for your time. We appreciate you joining us for this third in a series of FTC-specific webinars using LabVIEW.